Model benchmarks have become the battlefield of competing large language models, vendors, and research labs to show that their model is the best. If the benchmark, though, becomes the target, what can we really trust to guide us in model selection? In this video, I'll present some grains of salt to take when looking at the next best model, or our model beats this other model announcements online. You know the drill. But first, let's talk about what these benchmarks actually are and what they assess. What we refer to as benchmarks are actually benchmarking datasets, not to be confused with benchmarking models. The goal of benchmarking is to see if we can create a model which beats the published results on a given dataset by completing a standardized set of tasks. A so-called state-of-the-art model is the best one on a given dataset for a given problem. It's the title the fight is for. But when the industry itself is both a currently research frontier of science and a business opportunity, a conflict of interest arises. On one hand, researchers just want to figure AI out, and on the other hand, companies start competing for customers. There are quite a few benchmarking datasets for general purpose LLMs, so let's just get familiar with the most common ones. First one is the Massively Multitask Language Understanding Dataset, MMLU for short. This dataset measures general reasoning and comprehension acquired by models during pre-training. It consists of 57 categories of knowledge spanning humanities, social sciences, STEM, and more. Then there's Vino Grande, which is another dataset for common sense reasoning, but it's formulated as a binary fill-in-the-blanks task, which requires common sense to get correctly. The next one is Hella Swag, which is a challenge dataset for evaluating common sense natural language inference that is especially hard for state-of-the-art models, though the questions are actually trivial for humans. We also have JSM8K, which assesses mastery of grade school math, and Human Eval that's used to evaluate the functional correctness of model-generated code. So these are some of the most popular benchmarking datasets nowadays, but there are basically as many ways to evaluate LLMs nowadays as there are LLMs themselves. Okay, so these sound pretty reasonable, right? Yes, and we are by no means here to demonize these benchmarks. They are the only way to guide practitioners on which model to choose that doesn't involve testing every single model themselves. And they also provide a standardized way to measure the performance of LLMs across a variety of tasks. And they quantify the immense progress the field is making day by day. However, since AI became trendy and started attracting a lot of attention, everyone is keeping their eyes peeled on these benchmarks to see which model beats which, like they were watching gladiators fight in an arena. This has sparked an unfortunate trend in which the top of the leaderboard becomes the target, causing research labs and big tech to compete with one another to market their models as state-of-the-art. So how do you make sense of all of it? Well, don't buy everything they try to sell you online, right? Here are some things that you can keep in mind when you start reading the tech news. Big tech reported results should be taken with a grain of salt because, well, proprietary models can't usually be fairly compared to their competitors. So a couple of days after the Gemini model suite was released by Google, amongst them Gemini Ultra, the Microsoft OpenAI coalition responded with that GPT-4 beats Gemini Ultra on the popular benchmark MMLU by using a new prompting technique called medprompt. Problem here though is that Gemini's score on MMLU using medprompt was never reported, and so we have no clue what the score would have been using this novel prompting technique. This might have well passed as an interesting contribution to the world of prompting techniques, but OpenAI Microsoft clearly seems to try and one-up Google by announcing that GPT-4 shows better performance on this one particular task with this exotic prompting technique. And we are not defending either of these big tech companies here. They're both guilty of bending evaluation scores to fit their narrative. Here's another example. Gemini 1.0 Ultra announces the first model to outperform human experts and the previous state-of-the-art GPT-4, but again, we have no way to reproduce those results because we don't have access to the model weights. The second thing to keep in mind is that the benchmark performance is very sensitive, and with scores not being standardized in any way, companies might publish the single best score, for example, which does not really reflect performance robustly. A recently published paper called When Benchmarks Are Targets, revealing the sensitivity of large language model leaderboards, shows that for multiple choice question benchmarks, such as MMLU, minor perturbations to the benchmark, such as changing the order of the choices or the method of answer selection, results in changing in ranking up to 8 positions. When we take this instability into consideration, how significant and trustworthy are the results reported by the industry? For example, that the best Claude 3 model achieved 0.4% better performance on some dataset than GPT-4. It's hard to compare really, since they don't really report whether it was an average result over n runs, the best selection, selected, etc. The next thing is that we have no way of knowing why one model is better than the other. Models from Anthropic, Google, or OpenAI, they're fully proprietary, and meaning we have neither access to the weights of the model or insights into the training data. However, even for open source models like Mixtral from Mistral or Meta's Llama, where the code is publicly available, the exact training data remains a mystery. And there have been a lot of rumors that companies mix in instruction data at the end of pre-training, or that there's some other special sauce which could help improve those evaluation scores. While we don't know if those rumors are true, we can't really debunk them either. Without access to training data or code, little can be said with confidence as to why LLM evaluation scores are so different between each other. So, to conclude, take the benchmark, but take it with a grain of salt. The 0.4% advantage some model has above another could just be a marketing trick. Absolutely don't reject the benchmarks. They're great indicators of immense progress of the field. They're an actually standardized way to measure performance, and they're the only guidance in choosing models without having to personally test each one. But I assume you still want to develop some intuitions and learn how to establish which is the best model for your needs. If that's true, click subscribe, because in the next video we're gonna talk about what you can do instead to compare models and what is going to matter in the world of increasingly commoditized models. Thank you for watching.